All right, so if we're addressing the issue of methane leakage now, basically the methane leakage, as I see it, is simply not an issue in terms of global warming for a couple of reasons. Number one is what we know about it, what we've defined it quite well now. The leakage associated with the production of natural gas from unconventional sources is no bigger than from conventional sources, and the leakage at the site and associated with the site is a relatively small part of the total leakage. There's about 1.7% of the natural gas we consume is leaked, according to EPA, and about 0.8% is leaked at the site, and the rest in transportation and distribution and through pipelines and things like this. The leakage has been dropping, according to EPA. Their estimates had run about 3% of consumption, and that's dropped recently down to about 1.7% of consumption. And we can, and the amount of leakage that would begin to be of concern with shale gas development far exceeds 3%. As Howarth himself and others have pointed out, you begin to be as bad as coal at leakages of about 8 or 9% of consumption. Okay, now there are issues that have been raised about leakages that are not related directly to human activities, and these are already built into the system. We know that methane has been rising rapidly over the industrial era. We know that recently, in recent decades, it has plateaued and is not increasing anymore. It perhaps has begun to increase again. But the increase over the industrial area, which is quite dramatic, is related to all of the things that we do that release methane. Hydrocarbons being one of them, but only one of them. Right now, about 17% of our methane emissions comes from natural gas production. The rest comes from agriculture, cows, cultivation of rice, so on and so forth. And there are natural sources that are much bigger than either of these. So it's a mix of sources, the fossil fuels being a relatively small part at present, but a bigger part potentially in the future. And the system is in equilibrium with this present day mix of fossil fuel, of methane sources. So the issue is how much methane we're going to emit extra on top of what we're already doing in the production of future hydrocarbons and in the future agriculture and so on and so forth. And from the calculations I've done, it's very unlikely that methane is going to be a significant driver of climate change. And in fact, it represents a bit of an opportunity, because if you could reduce any of these sources relative to what's happening now, you would decrease the climate forcing a little bit, not hugely. The issue is CO2, and CO2 differs from methane in another very important aspect, and that is that about 50% of what we put in the atmosphere by combustion stays there for a very long period of time, 300 odd years or more. And so what we put in the way of CO2 in the atmosphere does not come out. Even if we stop burning fossil fuels completely, it will not come out, or come out very, very slowly. By contrast, methane, if we stop our extra emissions, it will come out of the atmosphere very quickly, with a decay time of about 12 years. So it'll be cut to 1/3 in 12 years and 1/10 in 24 years, etc. It comes out very fast. So if we see that methane is a problem, we can just stop and it'll come out very quickly, but the converse is not true for CO2. Now this is where the big advantage of natural gas comes in. It puts a lot less CO2 into the atmosphere than does coal or even oil. But especially coal. The emissions when you generate electricity, and that's the sole use for coal, significant use of coal, if you were to substitute natural gas for coal in electricity generation, you would reduce your greenhouse emissions of CO2 by about 40%, 40 to 45% for each conversion that you did. And that savings is perhaps the most important or most significant way that we could reduce our greenhouse gas emissions in the future. Simply converting our coal-burning electrical generation capacity from coal to natural gas would reduce the CO2 emissions about 45% of what could be done if we went immediately to low carbon energy sources for the electricity. Now, in terms of practicalities, there are other issues here. We are concerned about climate change here. We are a very rich country, and we have the perspective, rightly or wrongly, that we can afford to make whatever changes are needed. That is not true of the rest of the world. The rest of the world is impoverished relative to us a great deal, and the ambitions of China and India are to develop and have the standard of living that we have, and for that they need energy, and their imperative is to deliver that higher standard of living to their people by providing the energy infrastructure that's needed, and they're less concerned about where it comes from. So I think the best strategy for us would be to lead by example and show how we can make a transition from where we are now to where we need to be in the future in terms of carbon emissions by showing that we can reduce our emissions very substantially, and this is already, you can see this in the data, very substantially by making a transition from coal to natural gas, and then at the same time working hard on other low carbon fuels, including nuclear, so that we can make a more complete transition down the line.